Welcome back to Lesson 2B. In this lesson, we're going to draw our first two-dimensional shape, and we're going to put some dimensions on it. So finally, we're actually ready to start drawing. So of course, the first thing that we need to do to draw something, as we talked about in our first CAD lesson, is we need to pick a plane, because a two-dimensional drawing always has to be drawn on a plane in the CAD, on a plane or a planar surface. So the main window, remember, represents a three-dimensional space. It's not actually a surface. So we actually have to pick a plane to draw on. And we've got three that are available to us. We've got the top plane, the right plane, and the front plane. Now, mathematically, they're all equal. So does it really matter which one we pick? Not really. We can reorient an object and move it around and put it in whatever configuration it needs to be in to mate with other parts later on. But just from a logic point of view, if we think of a house, the front wall of a house is vertical, the right wall of a house is vertical, and then the top of the house is horizontal. So in our minds, top will be horizontal, the other ones will be vertical. In the case where we're going to make something that's cylindrical or cylindrically arranged, it's best to use the top plane as your first surface, as your drawing surface, so that the cylindrical part rises straight up from it, or as we learned in our first lesson, normal to that plane. Because we're going to be drawing a rectangular object, it doesn't really matter which of these planes we pick. So pick whichever one you like. Once you've picked it, you're going to see that there's going to be a rectangle of color around it. So like a highlighted rectangle, and it'll be a light blue color. That means that that's now active. So we can go up to the Features toolbar, and we can pick Extruded Boss Base or Revolve Boss Base. So we're going to make a rectangle that comes straight up from the surface in the shape of the contour that we're going to draw. So that's not a revolve, right? That doesn't do anything fancy, doesn't go around and around or anything like that. It just goes straight up. So straight up or straight down, normal to the plane, is always an extrusion. So let's pick the Extruded Boss Base. You'll see that as soon as we do this, the CAD is now kicked over into sketch mode and has activated the sketch. So you can see in the upper left that sketch mode is active. So SolidWorks has recognized that we want to do a three-dimensional object using the extrusion tool. So to do that, it knows we need a sketch, and then we need to extrude it. So it's kicked us over into sketch mode. We'll make our contour. We'll then leave sketch mode, and we'll come back into the 3D mode, and we'll do the 3D operation at that time. Within sketch mode, we've got our tools. So let's have a look at our tools. And if we want to draw a rectangle, what's a good choice for a rectangle? For this shape, a good choice is probably the two-point rectangle, which is the one that usually defaults up. You can switch the type of rectangle by doing the drop-down, the little tiny triangle right beside it. But in this case, drawing from corner to corner is probably pretty good because we want to locate it. And where do we want to locate it? Of course, we will always want to start any rectangular object so that the origin is at the lower left of the rectangular object. For a circular object, we always want to put the origin in the middle. And this is just a standard that's used in drafting so that we always know where the 0 is on our drawing. While this isn't completely strictly necessary to make things work here in the CAD world, in the CNC world, it is important if we're going to draw something later on that we want to impact with this object from somewhere else in space. If we don't know exactly where this object is, when we bring another object towards it to impact with it and become part of it, it's not going to hit where we think it's going to hit. It's always good to have these reference points, and that's why they build them right into the CAD. They give us the top plane, the front plane, the right plane, and the origin right off the bat, because everything in drafting is always measured relative to something else. So let's click on that rectangle icon with the white dot in each corner. That's going to activate the tool just with a single click. And we'll bring our cursor down to the upper left portion of our drawing window. Let's take a look at our cursor. It's no longer a triangle like it was earlier. Now it's a little crosshair on the 2016 version of the CAD, and it's a pencil on the 2019 version of the CAD. So your pick point, instead of being the tip of the arrow, is now the center of the crosshair on the 2016 one, or the tip of the pencil on the 2019 one. And also beside the cursor is an icon that looks exactly like the icon that we clicked on to activate the tool. And sure enough, that's what it is. It's telling us that that's the active tool. That little two-point rectangle is our active tool. If we now look over at the box on the left where our directory tree is usually located, you're going to see that it's now a toolbox for the rectangle tool. So whatever tool is active, or whatever shape you're looking at or line you've got selected, the directory tree will be displaced, and it'll be replaced with a box that gives you information about that tool or that line or that square or that rectangle or that circle or whatever you're working on. So in this case, you can see you've got your rectangle type, and there's 5 different types of them, and it says 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3. So those are your click points. Your first point is your 1, your second point is your 2. So to draw the rectangle, you click, release, move the mouse, and click again. The first click starts the shape, the second click completes the shape when it's a 2-point click shape. If you look at the drawing window, you're going to see that the front plane is facing directly towards us. We're looking normal to the front plane. That's the plane that we chose here in the lesson, at least. What the program has done is it's reoriented the drawing environment so that the plane that you want to draw on is normal to your line of sight. This is really important. If you're looking at a piece of paper on quite an oblique angle and you've got a square drawn on it, it's really hard to tell a square from a rectangle. But if you look at straight down at the piece of paper, it's very easy to tell whether that's a square or a rectangle. So it's always a good practice to look straight at anything that you're drawing in 2 dimensions. And the CAD does this for you, but fair warning, it only does it once. Every subsequent time that we go into 2D or back into 3D, we're going to have to manually reorient it. So let's take our cursor on the left side there, and we're going to drag it slowly down the left side of the drawing environment until something changes, and then I want you to stop. It's now stopped, and we've got a dashed blue line leading over to those 2 arrows, and then something right beside the cursor has changed as well. We have our 2-point rectangle indicator, and now I've got a little white box there with a dash through it. It's clear that the CAD's trying to tell us something. I'll give you a couple of seconds to think about what that might be. So what do you think the white box is? The white box with that slash through it. I often get the answer that it's a minus sign. Take your cursor now, and let's go up to the top of the drawing. Let's go across horizontally until something changes. And lo and behold, we get that blue dashed line, and we get a white box, and this time the line in the white box is up and down. Most students realize at this point that what that little line is telling you is that your orientation is vertical or horizontal. The dashed blue line, which leads to the intersection between the 2 arrows, tells you that that's what you're vertical or horizontal with respect to. And of course, what is that point where those 2 arrows meet? It is, of course, the origin. In this case, it's the XY origin. It's also the Z origin, but the Z axis, when you're on the front plane, is either going straight into the screen or straight out from the screen. This allows us to line up really accurately with the origin. Now take the cursor and move slowly down towards the origin until something changes. And you'll see when you get very, very close to the origin, 2 things are going to happen. You're going to get a little box, little yellow box with kind of a T in it. And you're also going to get a big fat orange dot right over the origin. If you play a little bit, you can see that you don't have to be right on top of the origin to get that dot. But once you're pretty close, you get that dot and you get that little yellow box. The box, if you saw that on a road sign at the country, you know you're coming up to a T intersection. And sure enough, that's what that box is telling you. It's telling you that you're at an intersection. The orange dot is an indication of one of the few CAD terms that's really quite intuitive, and that's called magnetic snapping. So if we were to take a magnet, a powerful magnet, and we were to hold it away from a metal surface, it's not going to pull on it very much. If we start to move it closer and closer, it's going to pull on it a little bit more, and at a certain point, it's going to pull on it so hard, it's going to pull it out of our hands and snap it to the surface. And that's what the CAD's doing here. If we think back to our first lesson and the open contour error, we were trying to connect 2 lines in space, and we were having a hard time getting them to connect. Magnetic snapping is kind of the antidote to that. So the CAD is indicating by giving us that fat orange dot, it's saying, I think you want to select this exact point, this intersection. I'm going to go give you this indication of a big fat orange dot, and if you click while that dot is visible, I'm going to start whatever you want to draw right on that point. So that allows us to very, very accurately position the start point right at the origin, or any other reference point that we want to use. So magnetic snapping also works for lines. You will get a fat orange line if it's going to snap to it, and it works for a surface on a model, like a flat surface on a model. You will get a thin orange outline of that surface if that surface will be selected when you click. We're actually ready now to start our first rectangle. So let's click once on that origin. Well, we've got our big fat orange dot, and then we're going to drag the cursor to the right and up. And I will let you decide how big it needs to be. We can reference the drawing that we made in lesson 1 to see how big it needs to be made. And you're going to find that it's pretty tricky to get it to exactly that number. So the bad news is you can't get it to exactly those numbers. The good news is it doesn't matter. Because we have these driving dimensions, we can sketch just like we do on the whiteboard and make kind of a rough sketch that's not really a proportion, and we slap on dimensions. On the whiteboard, we use it as a reference. In the CAD with driving dimensions, when we apply dimensions to our rough drawing, the CAD actually forces whatever line we dimensioned to be the size that we put in. This allows us to go through the very natural process of slapping out a rough drawing, throwing dimensions on it, and then when we edit those dimensions, we're editing the size of it. So we can draw it inaccurately, then edit our dimensions, and make it extremely accurate, because the whole purpose of CAD and of CNC machines is to make things really accurately. If we wanted to build something inaccurately, a chainsaw and a block of wood are much cheaper than a CAD and a CNC machine. If we're happy with the shape that we've drawn, and indeed it is a rectangle, and we wanted to draw a rectangle, we can go over to the rectangle toolbox and there's a check mark at the top. We can click on that and we've accepted it. But our rectangle is going to be kind of up and to the right. It's not very well centered, and it's also not really making good use of the screen space, so it's much smaller than it needs to be. So we're going to go and we're going to get to our Zoom to Fit tool, which is the leftmost tool on our view menu there. I'm going to click on that, and that will center it and make it nice and big for us. After that, we want to put some dimensions on this, and obviously the tool that we're going to use is Smart Dimension. If you hit the drop down below it for a second, you can see that there's a horizontal dimension, vertical dimension, ordinate dimension. There's a bunch of different options available. Smart Dimension just means that the CAD is going to guess which vector we want to put the dimension in. And it does a really, really good job of that, so we rarely have to use any of those other types of options to force it to be one particular type of dimension. We'll activate the Smart Dimension, we bring our cursor down, and we'll stop off the drawing there, and sure enough, beside our cursor, there's a little dimension icon telling us that that's our active tool. So we're going to dimension the top line first, and we want to avoid the end point, the midpoint, or the other end point. Because when we're dimensioning, if we pick a point, we're going to dimension from that point to another point. So any dimension that goes to a point is between something. If we want to get the length of the line, then we have to select the line and only the line. We're going to stop drawing for a second, and we're going to take a little break, another theory break, and we're going to talk about how dimensions, lines, surfaces, and entities interact. And of course, you're thinking, what's an entity? Well, in a horror movie, the entity is the unseen ghost that causes a bunch of trouble, and they don't have to spend any money on CGI to animate it because you never see the thing. In a business, an entity is an unseen business that exists on paper and doesn't seem to really do anything except allow really rich people to put money in offshore accounts. In terms of CAD, it actually has a specific meaning. Now, I don't know if this is the correct technical definition, but this is a working definition that we use here in the Science Maker Lab, and it works really well to help people understand what an entity is in the CAD and what it does. If you can select it and only it, it's an entity. So an entity is the smallest individual item that you can select in a CAD. If you can select it without having to select something else, it's an entity. The flip side of this is we have to select entities to do any dimensioning. To understand how an entity interacts with the type of objects we're trying to measure, let's take a straight line. Now I'm going to ask you how many entities are in that simple straight line. And I'll get a guess often of 1 or infinity. And the correct answer is actually 4. We've got a beginning point, an end point, we've got the line between them, so those are 3, and then the CAD supplies us with a midpoint. It's often helpful to be able to find the midpoint of a line without having to take a measurement. Or, if we want to put something in the middle of a line and then later on we change the length of that line, it's nice when it doesn't move because it's not measured from one end, it's actually measured right to the middle. So the CAD supplies us with these points that we can pick. If we take that same logic and we apply it to a circle, how many points do you think we have on a circle? Or sorry, how many entities do you think we have in a circle? And here the correct answer is actually 6. So we've got the center point of the circle, and that's used to locate the circle, like the axle of a car. Where the axle is where the wheel is. We've got the line that goes around the outside, that's the circle. So if we dimension that, we're going to set the diameter or the radius of the circle. And then the CAD very kindly supplies us with a point on each quadrant. So where that circle goes through the other planes, there's going to be a point. Top, bottom, left, and right corners, if you will, of the circle. And these are all handy because they help you to get things lined up. In my old CAD, in the 1997 CAD that's in the second computer in the lab, these kind of grab points are referred to as handles. So if you think of an entity as kind of a handle, when it's a point on a line or a circle or something, it's a pretty handy analogy and gives you a good idea of how it works. So there's a little bit to kind of keep in mind as you're dimensioning something, but where there's a little bit of complexity to it, there's also a lot of power to it. So if we want to take a block of wood, for example, and we want to drill a 10 millimeter hole in the upper right corner, 10 millimeters down from the corner and 10 millimeters in from the one side, then what we can do is we can draw our cube and extrude it. And we've got our cube, we dimension it. We can then click on the top surface of that cube to make it the active drawing plane. We can then take a circle and we can slap it anywhere on the top of that as long as the line of the circle isn't touching the outside. If the line in the circle is touching the outside, you're going to see a little box with a circle in it that touches a straight line. And of course, the touch between a straight line and a circle where it doesn't cross it, but it just barely touches it, is called a tangent. And what that means is you'll set up a tangent relationship between that circle and that line. And no matter where you move the middle of that circle, that line will stay attached to that circle and the circle will just get bigger or smaller. We want it to be free to move, so we just put it somewhere in kind of no man's land on top of this cube. Then we can take a dimension and we dimension from the midpoint of the circle, the center point of the circle, to the line, the vertical line on the cube. We want to be at the line. We don't want the points. If we get the midpoint or the bottom point, we're going to get a dimension that goes on an angle. But if we dimension to the line, any dimension that goes from a line that's not on a point on a line, just the line itself, and goes to another thing, is going to come off that line normal to that line. That's what we want. We want horizontally, how far is this circle from that edge? And we'll set that to say 10. And boom, our circle's going to move over to the right. And it's now 10 millimeters or 10 units or whatever we're drawing in from that line on the right. We repeat the process with the top line. We then click on the line of the circle and we can set the diameter to say 12.7, just a random number that happens to be a ½ inch. So most things that look about that size in North America, where a lot of our measurements are imperial, is going to be a ½ inch. Now we've got our circle, it's in the right spot. We can just extrude it to whatever depth we want with an extruded cut. Because remember, we cut to remove materials, and a boss and base add material. Might be a good time to explain what the difference between a boss and a base is. A base is the first solid object that you draw. A boss is anything that sticks out of it. So if you think of lettering that sticks out of your hat, that's embossed lettering. So it's a little obtuse and a little unnecessary. What you really just need to remember is that if it's a boss base, you're adding material. If it's cut, you're removing material. Let's get back to our actual drawing here. We'll take our Smart Dimension tool. We're going to dimension that top line. We're then going to take the dimension. We're going to put it about 1 font height up off of the line that we're dimensioning. We don't want to be too close because then it gets very cluttered and difficult to read. If we put it too far, when we do the zoom to fit, it's going to leave white space around our dimensions and the part itself will be kind of small. So about 1 height of the font is a good distance, and we want it to be in the middle, because if it's in the middle of the line that we're measuring, it's quite intuitively obvious what line that dimension applies to. But if we had a drawing where we had several dimensions on the same vector, say 3 horizontal dimensions, and we stacked up the numbers on top of each other like the actual fonts, it's going to be difficult at a glance to know which dimension, like which number applies to which of those horizontal dimensions. This means that it's a good practice to put your dimensions in the middle of the line that's being dimensioned whenever you can. And in this case, we've got nothing that's preventing us from doing it, so we can easily do it. When we've got that in position, we just click once, and that will set our dimension there. A number will pop up, so we can see what our dimension's at. Right now, mine did not say 80 millimeters, which is what I wanted it to be. So to edit it, if I click on the dimension line or any part of the dimension other than the number, that means that I can move the dimension or delete it. If I click right on the number and double click on it, I'm going to get a little box that pops up that says Modify, D1 Sketch 1. And I've got 138.47 millimeters in the example that I was doing while I was recording the audio. The entire thing's blue, which means that if I type over it, it's going to change the whole thing. So I'm going to type in 80 mm, and I'm going to hit enter. And now I've got a dimension of 80. If I double click on it again, this time what I'm going to do is I'm going to ditch the mm. I'm just going to go with 80 with no units, and I'll see what I get. And I've got my 80, so I double click on that, and sure enough, it's 80 mm. So what does that mean the default unit of measure that we're working in is? Yes, it's in millimeters. That's something we can set. We're free to change that for every drawing. We can set a different default for every drawing as we need it, but because both of our laser cutter and our 3D printers work in millimeters, we tend to just leave it in millimeters unless there's some special need, such as working with stock materials from a machine shop or something like that. If we buy steel, we're going to be buying 1/2 inch plate, not 10 millimeter plate, not here in North America at least. So we now know that we don't have to put in units if we just wanted to go to the default unit. But what happens if we say take the 80 millimeters and we'll change that and we'll go 50 mm and we'll go plus and we'll say 1 IN, 1 inch. So if we were to do this in Excel, mix these units, we'd be in a bit of a problem, right? So let's just press yes here and see what happens. And we get a result of 75.4 millimeters. Because the people who design this know that engineering in North America is a hodgepodge of units, imperial units and metric units, my favorite one being the milli-inch, the 1/1000th of an inch, which is what you measure a thousandth of an inch in if you're measuring a plastic bag or a film. But if you're doing machine work in a machine shop, you call them thous. Can't figure it out. It is what it is. The beauty of it is that the CAD handles it. It goes through the equation, it looks at each number, looks at the units, converts everything into the default unit, and then does the operations, which is sweet, particularly if we're working with millimeters, but we're working with imperial stock sizes of material. We don't want 75.4, we just want 80, so we'll double click on that again, we'll make it 80. We can see that our Smart Dimension tool is still active, so we'll just grab the vertical side, and we'll set that to the 60 that we put on the whiteboard earlier. Drawing kind of jumped a little bit and it's a little bit off the chart here, so I'm going to hit my fit to window again, or zoom to window, and reset that, and I'm going to say yes to this rectangle. To keep this video reasonable in length, we'll stop here for now. When we come back in Lesson 2C, we'll talk about a common error that we run into when dimensioning. See you then.